It's quadratic time. It's quadratic time. Whoa, it's quadratic time. If you haven't seen the YouTube song, it's really just a song. You don't really see it. It's just me and a tie. I've got a quadratic equation song. I think it's wonderful. It's like Billy Joel's For the Longest Time, but quadratic time. If you remember the quadratic formula, essentially what we're looking at here is we're trying to set up that x is equal to negative b, or the opposite of b, plus or minus, because there's two possible solutions here, the square root of b squared minus 4ac, all divided by 2a. And these a, b's, and c's we have here are all coefficients. That means the number in front of some second order polynomial. So this will be like a, b, c, x squared plus bx plus c equals 0. Okay, and this is what we call standard form here. And if you have that and you have a, b, and c, and they can be positive or negative numbers, and you shove them into the quadratic equation, you run it once for the positives, and then you run it again for the negatives. You get two answers, and boom, you've done it. You are the victor. You've just run the quadratic equation. We oftentimes run this in physics in kinematics. In my classroom, specifically equation number 5, it's that delta x equals the initial velocity times time plus 1/2 at squared. If you haven't seen or listened to the Teach You Again song on YouTube, highly recommend it. So basically, this right here is set up to be solved with quadratic. We've got a squared term, we've got a term to the first power, and we've got some constant c. So if I wanted to set this up in standard form, it would be like 1/2 at squared, where that's a coefficient, plus vit, where this right here is a coefficient, and don't forget about the plus or minuses in front depending on what you have, and then minus, because I'm bringing that delta x over, delta x equals 0, where this minus delta x is some coefficient. Okay, that's our a, b, c. That's the most often time we use that for what we're doing in physics this year. So if you're able to do that, if you're able to use this equation, put something in standard form, and recognize your a, b's, and c's, you can run a quadratic equation. But what we are setting out to do is go, hey, that's a nice little equation you made up there, Coach Botzer. Where did it come from? So let's figure out where in the world this equation came from and derive it, okay? If you're like, I don't care, then find a new video to watch, because this may take a while, or it may not, who knows. We'll start with standard form. So we have a x squared plus bx plus c equals 0, okay? And what we're going to do next is we're going to divide this entire equation by a. So whenever we do that, when we divide the whole thing by a, our a's are going to divide out, but an a has just popped up everywhere else in this problem. Now technically when you divide the left by a, you're also dividing the right by a, and the question becomes, what if a equals 0? Didn't we just break the laws of nature? Okay, you're right. If a equals 0, we broke the laws of nature. But if a equals 0, then that means the x squared term went away, and we no longer need to use the quadratic equation. So that's not a problem we're going to encounter. So if I divide by a here, I get this. I get x squared plus b over a x plus c over a equals 0. Okay, cool. Now we are going to subtract this c over a onto the other side. So we now have the equation x squared plus b over a x equals negative, because we subtracted it, c over a. So we've just done a little bit of algebra fun side, okay? Now, this is just like where you pull this from. This is why we have mathematicians in the world. Some people are just really good at seeing this kind of stuff. And if you're one of those people, like, that's awesome. Go do crazy math. Go have fun with it. You know, create new ideas with it. Create new computer equations. Like, do everything cool, okay? But what we're going to do right now is we are going to add b over 2a squared to both sides. That's an A. Just roll with it. Let's just do it, okay? So here we go, new equation. We now have x squared plus b over a x plus b over 2a squared equals negative c over a plus b over 2a squared. Okay? Now, the reason why we're doing this is if you saw this, you had that intuition, inside of you. This right here becomes a perfect square. Okay? That becomes a perfect square. So we can rewrite it as follows. We can rewrite it as the quantity x plus b over 2a quantity squared equals minus c over a plus b over 2a squared. Knowing that, like, hey, if I just add this quantity b over 2a squared to each side, that'll make me a perfect squared. That is not an easy thing to recognize, okay? But it's something we can see. So when we complete that square, this is what we get down here in red, okay? So now what we can do is we can start playing around with this a little bit. If I want to get rid of this square here, what I can do is I can take the square root of both sides. When I take the square root of the left, it gets rid of that. When I take the square root of the right, then I get whoop, this big old square root. Okay? And if we think back to what we know about square roots, when I take the square root of a number, I technically get two answers. I get a positive and a negative answer. This is because if I look, for example, at something like, what's the square root of 4? Well, most people will say that's 2. Well, what if I had negative 2 times negative 2? That equals 4. So really my answer for the square root of 4 is plus or minus 2. It could be either of them. So with that, I can take the equation in red and I can write it as, we'll get a new color here. I can write it as x plus b over 2a equals plus or minus the square root of negative c over a plus the quantity b squared over 2a. That's what I'm looking at. And hopefully now as we start to look at this, we start seeing where some of these quadratic terms are coming from. I've got this negative c, I've got the b squared, I've got the plus or minus. Okay, like we're getting there. Let's now pull this b over 2a to the other side. So we'll subtract it from each side. So now what we have is x equals, subtracting the b over 2a over, gives me minus b over 2a, and then plus or minus this big square root. So square root of negative c over a plus the quantity b squared over 2a. Whoops, excuse me. Typo. B over 2a quantity squared. I messed that up. Did I mess it up higher anywhere? No, we're good there. Okay. Close out my radical. Whew. At this point in time, we are technically done with the quadratic equation. That's it right there. It just doesn't look like it. We have our negative b term. We've got a b squared minus some c. There's a 4a popping up somewhere. We can just make this look a little neater. If we go and simplify it a little bit, if we go ahead and multiply the right side by 2a over 2a. It's a weird thing to multiply by. It's one of these math intuition things. 2a over 2a is equal to 1. It's the same numerator and denominator. But if we multiply by 2a over 2a onto the right side, well, what we end up seeing is a lot of helpful stuff happen to us. We begin to see that this 2a and 2a are going to wipe out. And what we end up having is that x equals negative b plus or minus this crazy root term, negative c over a plus b over 2a quantity squared, all divided by 2a. That was the 2a right there. Whew. And if I go and simplify this root right here, well, we'll do this to the side. That could be written as negative c over a plus b squared over 4a squared. Well, that 4a squared there, we can start playing around with that a little bit. How do I want to do that? If I multiply that, you know what? I'm going to do this. That's not how that happened. That 2a stays there. This 2a right here can actually be brought inside to clean things up. That 2a right there can be written as 2a to the quantity squared, because there is a big radical hanging around here, and those radicals and the square will cancel. So what will happen though is if I leave this as 2a squared, 2a squared is 4a squared, so those go away, and that's actually multiplied by this quantity. So this 2a squared, or the 4a squared right here, get canceled out to that, but it also applies to the c. This is why this one stinks to derive. So you end up getting a square root of negative 4a squared c over a plus b squared, and then one of these a's cancel out. So there's your, if we rewrite it, root of b squared minus 4ac. Ugh. Okay, because that distributes to each quantity. That was a bit of a pain. So in the end, we do get the quadratic equation x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Oh boy, wasn't that fun. Yeah, you'll never have to memorize that derivation. That's a bit of a tricky one. It took some serious mathematical intuition to get to. But in the end, we do have the quadratic equation here. It's one of the very important equations that we have in our toolkit in order to solve a second order polynomial, such as we have in kinematics if something is in standard form, because we have a, b, and c for our coefficients, so we can just plug them in for a, b, and c. Note, when we have this quadratic, we need to solve it in two ways. We need to get a positive and a negative answer. What will often happen in the world of physics is if you're solving this for time, you'll get like a positive number for one of your answers, and a negative number for the other one. And that negative number, it's a bad number. It's non-physical. Meaning that if you went through some negative time, what you've really done is you've time traveled backwards. Like, nobody ever says, you know, I was brushing my teeth for -2 minutes today, because that doesn't make any sense. So oftentimes in physics, we will get two answers, but we only care about the positive or the real physical answer there. So that's just something with the quadratic equation that's a little weird in the world of physics, even though in mathematics you often just want both quantities. That pops up as well whenever you're trying to solve for spring constants. If you're doing differential equations, you only take the positive value, as well as a few other things. So it just really depends on what you do, analyzing that problem for what you get there. But that's the quadratic equation in a nutshell. Definitely worth knowing, and definitely worth listening to that quadratic equation song up on the YouTube. So with that, quadratic equation is finished.